For the past few months, I've been working on looking at to see if and how the 200 point p-bag in Palace 1 could be manipulated, if it could, and if so, how it could be done. And the TLDR, for those of you that don't want to sit through all the technical details here, the answer is yes. There is a single frame where the 200 point p-bag is guaranteed to drop. It'll be, of course, a one frame, frame perfect kill on the stalfos, but it is definitely doable. If you kill the stalfos exactly 165 frames after the screen renders, that was the result of my analysis, 165, a p-bag will drop 100% of the time. Appended to this video at the end, I've included some actual gameplay that targets this frame, so you can feel free to skip right to that if you're not interested in all the details here. The timestamps I will put in the description. So I'm going to go on to the details now. If you want to avoid all the math and talking points, now is the time. So to start, I wanted to quickly give a shout out to Fontu-D2 with his Magic Cave explanation video. I dissected that video quite a lot to get started with this project, and it was really helpful. I will be going over a lot of the same details, but feel free to check out his video if any of this doesn't make sense. His video had some better graphical elements and is overall better produced, in my opinion. I'm just going to be kind of talking and showing what I'm referring to here. So to start with, the RNG algorithm. Let's talk about how the RNG works in Zelda 2. There are 9 total bytes that get used for RNG, and different mechanisms inside the game just picks some of these bytes, some of the bits in this stream here to do the calculations with. Up here on the screen, there's 9 total bytes. We're only interested in the first 7, but we'll go over that later. So I've got some gameplay in an emulator. We're looking at the memory viewer. And then on the right-hand side here is just a quick overview, some reference material, binary to hex conversion, the XOR table that shows the output of that calculation. And then finally, if it's a large drop and we want it to be a p-bag, these are the values that it's looking for in the RNG sequence. 3 bits, and those are the ones that are looking for those 4 options. There are 4 more that produce a jar. Finally, the RNG algorithm, which I will go over now. So memory is just a series of binary bits, 1s and 0s, of course. They're separated into bytes usually, and those bytes are represented by 2 hexadecimal digits. Each hex digit is 4 bits. So 8 bits total makes 1 byte is 2 hex digits. That's why in the memory here they're all bunches of 2. So that first one that I've got highlighted, A9, that's where the RNG sequence begins at address location 51A. So I'm going to switch over to this other screen here, this one, and let's actually step through the algorithm. When the game first loads, when you're on the title screen and everything, it's all zeros. This whole section of the all the RNG bits are all 0. And then when you first enter North Palace, there's an initial seed that happens. So let's just say, for example, well, I can tell you what it is. It's A500. So that is in binary 1010 0101, and then all zeros. 1 2 3 4. Yeah. So if we are going to perform the RNG algorithm, the RNG is calculated every frame, except for a couple of lag frames, which are not important, that deal with just internal calculations during screen transitions mostly. But every frame, every reasonable, most of the game frames, RNG is updated. The way that works is it takes the second to last digit in the first byte and the second to last digit in the second byte, and it does XOR on them. So this right here, XOR. Whatever the result of that is a new bit that goes to the beginning of the string, and everything shifts over. So if I was going to look at a frame progresses and we're in frame number 2, essentially, we've got a 0 and a 0. So according to our reference, XOR 0 plus 0 equals 0. So our new bit is 0, and then everything shifts over. So I'm just going to copy it down. 1 0 1 0 0 1 0 1 1, and then we got all zeros after that. The rest of the digits continue on all the way down to the 9 bits, and then the final bit is dropped. So in hex, we're going to see, let's see, this is 0 1 0 1, which is 5 in hex, and then 0 0 1 0 is 2 in hex, and then 1 0 0 0 is 8 in the second half here, and then all zeros at the end. All right, so that's our second frame. Let's do it again. Now we have a 1 and a 0 in those 2 digits. 1 plus 0, the XOR is 1, so our new bit is 1. So it's a 1, and now we shift everything over. 0 1 0 1 0 0 1 0, and then 1 0 0 0 0 0 0. Everything's shifted over. So now we've got 1 0 1 0, which is A, and then 1 0 0 1 is 9, and then 0 1 0 0 is 4, and 0 0 0 0 0. So our first 3 frames of the game, it's going to initial seed of A500. The second frame 5280. The next one is A940. So now let's go back to the video. I backed this up a few frames so we can see that the initial seed is 0. Oops, right here. Now we're gonna step through this. So we're gonna find where the first frame is. Oh, and there it is. The very first frame is A500. A500, and all the rest are zeros, right? So A500. What did we calculate the second one was? 5280. So let's make sure. Let's step through. The next one is 5280. There it is, 5280. Next frame, A940. A940. And it continues. And you can see eventually, if I step through, you can see that the value is propagating through the rest of the RNG all the way down to 9 total bytes, and then it stops. 1 2 3 4 5 6 7 8 9, and like I said, only through number 7 are we going to really care about. So this happens on every I guess every frame of the game. The RNG continues with basically one exception. The game reseeds the RNG sequence every time a side-scrolling screen loads. So within the palace, every time you go to another side-scrolling screen, it will reseed. And by reseed, I mean no matter what this RNG sequence is, this first byte will be reset. And what's interesting is we'll notice is it'll always be reset to A5. Trying to the A5 in binary is 1010 0101, kind of a way of splashing a bunch of random digits in there. It just happens to be the same one every time, which is extremely interesting. Let's go take a look at that. When you go to the overworld, it will not reseed. The next time after, yeah, I did a couple of stabs here. This is just a recording in the emulator. Okay, so we're going to just step through this. And it will always, yeah, it stops. There's a bunch of lag frames, and then, all right, 1 frame before it loads, CD, it did not reset. But the next side-scrolling section is, I'm going to just sort of jump ahead here, is Magic Cave. That'll be the next side-scrolling section of the game. And let's take a look. Let's go to the darkness before that starts. And let's get into the where the screen starts. All right, back it up. Here's where before Link gets rendered, and then 1 frame before this is when the rest of the screen renders, and we got A5. A5. The first byte of the RNG sequence always resets to A5 1 frame before everything renders on a side-scrolling screen. So it's extremely interesting. That means that every time you go into a new side-scrolling screen transition, remember what I said about the RNG algorithm. Only, 51A, the first byte, is reset to a known value, which means byte B, or this bit actually is the only one that matters, but the byte and the significant digits before this that could affect it are the only possible new seeds that can happen on any side-scrolling screen transition. What that means is, I'm going to switch back to this other view, is that this will always be A5, and this is the digits that's significant, so these are the digits that matter. Everything after that is just residual RNG behavior. Everything continuing on, it just propagates throughout. But the only thing that matters for determining what the entire RNG sequence is, it's this up to here, the significant digits that come before the two that are used in the calculation, but we know that this is the same every time during a screen transition. So these are the only ones that matter. Those 7 bits. This was one of the first major breakthroughs in trying to manipulate this p-bag, was that there's only so the total number of possibilities with these 7 digits is 128 total possibilities, 2 to the 7th. So that means there are only 128 total RNG seeds in the entire game. So armed with this knowledge, let's take a look at how the drops are calculated. I'm just going to switch it back to video because why not? Give you something nice to look at. There. So it might be common knowledge, but it's okay to restate. There are 6 slots that items, enemies, any objects can occupy in the game. So if all 6 slots are full, then nothing else can spawn. You get despawns that way, right? So there's only 6 available slots that anything can go in. Also important to know that as enemies spawn, those slots fill up from the right to the left. So it goes to the lastmost slot and then works its way in. So think about the critical area here. The critical area that we're trying to calculate is the stalfos. This screen, you're coming up the elevator, a screen transition occurs. There's only one large enemy on the screen. Okay? That large enemy will always be in the last slot because it's the only one here. So remember how I said that only 7 bytes of the RNG sequence are important? This is why. Because we've got this RNG sequence right here, all the way to here, right? So this is the first seed, and then we got the 6 slots. It's going to use starting with the second one, because the first one could get reset, but the second one is really where the randomness, the developers just considered this is where the randomness begins. So 1, 2, 3, 4, 5. The 6th slot is byte 520, and that is the only place we look. It will the drop for this 200 point p bag or jar, the red jar, will be decided by the value in this byte, always. That is interesting. And we know that coming up the elevator, the first byte is always going to be reset to A5. So there's only 128 total options, and it's going to occur, and we can look at only this byte to figure out what our total options are. When it's actually doing the calculation, let's go back to this right here. The drop table is there's 8 options in the drop table, so you need 3 bits to get 8 options. 0, 0, 0 through 1, 1, 1. There's 8 different possibilities there. So what it does is whatever slot it's in this case this slot right here in 520, the 9D right now that's showing up, that byte it's going to take the last 3 bits of 9D, and that is what's going to do the lookup for the large drop. And it'll correspond to one of these 3. So let's just say, for example, this is 9D. Let's figure it out. So the 9 is in the first half of the range. So a 9 would be, well, let's write out 9D. 9 is 1001, and then D is 1101. 9D equals that. So the last 3 bits of this, 101. Let's look it up in the table. If I got a drop on this exact frame, it's not this, it's not this, it's not this, not this. So this would produce a jar drop. Let's go to the next frame just for the fun of it. What's E? The next frame is 4E equals 4 is 0100, and then E is 1110. Notice that these digits are just shifted over by 1. These 3 ones are just shifted over by 1. So in this one, the last 3 digits is 110 for E. There's 110. Got a bag. So the next frame in this case would be a bag. So putting it all together, when you come up the elevator, the stalfos is always on slot 6, or the last slot. We know the beginning is always, or the first byte is always A5. There's only 128 total seeds. So that means we can run through every possibility of this RNG sequence, starting with A5, with the second byte being all zeros and the second byte being all ones, every combination in there, all 128, and see what our chances are on any given frame, which I did. I'm going to take you to my database. This is a SQLite database, a flat file. I will make this available to anybody. Oh, this is right. It's got the seed number, frame number. This is actually the one I want to be on. Seed number, frame number, the binary representation of those 7 bytes, the hex version of those 7 bytes. And then just for completion, I put the drop, whether it's a bag or a jar, from each of those slots for every frame. That way, if anyone wants to do any number crunching on this, all the data is here. So what I did here was I'm just adding up across all seeds per frame, grouped by the frame. What are the chances of this being a bag? Now the first, 30-something odd frames don't matter because we're waiting for the full sequence to propagate. But what we're getting here is, starting at 39, these are all jars because my beginning was all zeros in that frame. But now is when, starting with 39 is when that sequence starts to take over, where the whole sequence is now fully propagated. We can get our actual values, percentages of this happening. So in frame 39, 64 out of the total 128 seeds produces a bag, which in this case happens to be exactly 50-50. So half the seeds produce a bag, half of them are a jar. So we're looking for any peaks in here. Here's a couple of zeros, here's a couple of 128. So if you were able to get a drop on frame 50 or 51, you would be guaranteed a P bag. If you got a drop on 49, 48, or if you're off by a couple of frames, it would definitely be a jar. Right? These are not a bag because I was just counting bags here. So we're looking for 128s or anything higher than 64. But you can see there's a lot of 64s. This is all 50-50. This isn't really what I wanted to see, but let's just keep going here. And you'll notice, what's this? 165. There's a random peak in here. So if you were able to get a drop on frame 165 exactly, you would be guaranteed to get a P bag. If you were 1 frame early, you would get a jar for sure. And then everything surrounding it is all 64. It's all 50-50. This ends up being very close, surprisingly, to what optimal strat would be for the room. In fact, optimal would be a little bit faster. It's like right in here, with a good elevator exit and then a pretty swift kill on the stalfos. So all you have to do is delay it a little bit, and you're going to aim for that 128. Like I said earlier, I've got some gameplay that shows this at the end of the video. Continuing on, let's just look at the rest of these seeds. It's all 64, all 64. This is all 50-50 on all the seeds. It's not until we get to 500 that we finally get another peak. This is probably just a circumstance of the 5e, the fact that the bit sequence is 10100101. There's 2 zeros in the middle, so every once in a while that's going to converge on it being like a perfect match on every seed. There's a couple other, flatting out zero, but this is all 64, 64. This is all 50-50. What this actually tells me is that the developers did a really good job making this even, making this a 50-50 shot. So, the next question, how hard is it to target frame 165? The answer, it's hard because it's frame perfect, but it is doable. It is doable. And not only is it doable, it's really close to optimal strats. It ends 165 frames is about 2 3/4 seconds, 2.75 seconds ish, give or take. So, knowing that, what additional questions can we have before we go on? Can we get any better than this? My first question was, based on the RNG progression, are there any seeds that are more likely than others to happen? So if I were to just look at all the seeds and how it progresses through the game, is anything just, how we've got a couple of these peaks in here, are any seeds more likely than others to happen? Well, we have data to prove that, or to not prove it, but at least help us suggest. This is the query that I put together. Basically what it does is it tries to predict on a specific frame what the most likely seeds are to get. So if this is 168, if I did 165, as this is another good way of showing it, 100% bags. You'll always get a bag on frame 165. So what I did here was I took the entire output of the RNG sequence between 0 generation and 30 seconds in, so that's 1800 frames for every seed, and did a count on how on the uniqueness of byte 2. So this is the seed that's responsible. This is the specific 7-bit digits. How many times that happened in byte 2, anywhere in any of the progressions. And what you can see here is there is a weighting to it. A couple of them are identical here, but 1397, so like almost 1400, and then the lowest one is 1207, so that's 200 difference out of 128 total options. So that's a difference between, here's the percentage, 0.83% compared to the least likely is 0.72%. In other words, not a significant difference. If anything, it might push it one way or the other by a couple of percentage points overall. But in the end, this doesn't really tell us much. One thing I can do, going to the next frame, 166, if you're aiming for that 165 and you're late by a frame, the other thing I did here was I removed the first 495 frames from the calculation because you can't realistically finish a screen faster than that, where it would reseed faster than that. But you can see with that, the most likely ones, 1, 2, 3, 4 out of the top 10 are bags, but a lot of jars in here. And then the chunks, this is still about halfway, halfway down the list. 64 would be halfway. Let's try 2 frames late. It's still, it's going to be 50-50, but we're looking at, is there anything really heavily, like is there a bunch of bags or a bunch of jars in the beginning? This one has a bunch of jars in the beginning, but here's a bunch of bags, so it's kind of even. It's kind of even. So the answer to this question is any one seed more likely than another seed? The answer is not really. Everything's pretty well randomized out so that we're getting an average look at every seed hitting it. Even the all zeros and all the one seeds still happen. I thought one was kind of close to the bottom. Here's all the zeros, all zeros and a one on either end. So you can see the non randomized ones in all the different places kind of happen less frequently than the others, but they still happen plenty of times that you have to account for it. The second question that I had after figuring this out was, can we do anything else to limit these numbers of seeds? And the only other question I could come up with was, can you play frame perfectly from the beginning of the game? And the answer is, not really. Not enough to be optimistic about it. This was exactly why I started going down this path of trying to manipulate the 200-point bag, was because I was thinking with reverse bubble skip, you can predict up to very couple of frames, within 20 at least, probably a lot closer than that, which exact seed you have going into Palace 1. Entering Palace 1 is basically frame perfect or very close. But there are a couple of frames that could be different. But if you could get really close on that, there's a bunch of screens in Palace 1 that are just, killing tin suits and getting across the screen as fast as you can. So that's all predictable. But there are elements that are not predictable, even if you play really well, even if you try to play really consistently. Those things are bots jumping at you, any damage whatsoever. So first of all, you got to play without any damage through this 200-point P-bag drop. Elevator entrances and exits. There's a few stalfos kills in there. Key grabs. There's a couple of key grabs. The Guma. There's 2 Gumas you got to take out. So all those things kind of add up to mean every screen transition where there's anything variable will just make it exponential. And so even if you could target a couple of frames, it would just continue on for every couple of frames, every couple of frames, it just multiplies. And because the reseed happens every screen transition, it's not the case that you can be early by a frame on one screen and then make up for it later by being late by a frame on the next screen, because the seeds is completely different by that time. So it doesn't work out that way, unfortunately. So you have to play frame perfectly to get here. So is it impossible? No, but I'm still working on that. I'm not really optimistic. So so now it's time to go into the gameplay. Really, the best case scenario here is targeting that 165 P bag. We're going to be I'm going to be adding that video in here shortly, and the specific seed that I'm on during that video is seed number 81. I found this out through a lot of trial and error, but I am on seed 81, and I'm targeting, if I scroll down, this is the actual output for seed 81. If I go down to frame number 165, right here, frame 165, I'm aiming for, I'm using here's the P bag. I'm using the practice ROM that shows which RNG hex value you got that produced the drop. In this case, E1 is the one I'm aiming for, but during that gameplay, you'll see some of these other ones show up. C2 is 1 frame early. That's 100% of the time a jar. 84, 70, 38 are a couple of frames late. 1C is 3 frames late. That produces a bag. 0E is a bag. So you'll see, I can kind of with the gameplay that I'm working on, we're targeting E1, or if you can't get to E1, you want to be late more than early. But this is sort of what we're aiming to get is E1, or kind of within that range, where 3 out of the 5 of those are bags. This is some gameplay that will show a strat that I've been using to try and target the 165th frame after the reseed happens, coming up the elevator, to get this 200-point P bag. I'm using a practice ROM that shows the drop RNG value that's being used to produce the bag. You can see it in the top right corner, RNG arrow E1. in this particular seed, which I have a save state right before coming up the elevator, it happens to be the reseed number 81 out of the total 128 possible RNG seeds in the game, at least for drop purposes. Through some analysis that I've been doing recently, I determined that the 165th frame, there's a peak that drops the P-bag 100% of the time across every seed. The 164th frame, if you're one frame early, it's 100% ajar. So, and then everything else with a margin on either side is, averages out to 50% perfectly. There's a few peaks in the sequence, but right around this 2.745-ish seconds after coming up the elevator, or after the reseed happens, 165 frames, there is a peak that produces a P-bag, so it's actually really nice that it's right there. What I've been aiming for to try and target this frame, it's frame perfect play on the screen, but I try to go up the elevator, and right when my head touches the top, so the elevator is at the max height, it's even with the top of the platform here, that's when I start going. On this one, I don't try to exit early like this, then you'll be too fast. So if I come up the elevator, right there is when I start going, kind of right when you bonk your head. I'm going to do it a bunch of times. I probably won't get it a ton because I'm still learning it, but that's what I'm aiming for, to try and get to this E1, which on this seed is frame number 165. There's other ones. C2 is 1 frame early, 70 is 1 frame late, 38 is 2 frames late, 1C is 3 frames late, and you would rather be late than early, so 165 frames, according to my reasoning, I'm thinking if I bonk my head and go, or go up and then go as fast as you can, and then do this 3-hit kill, you generally won't be early. You'll either be as fast as you can at 165, or you'll be a couple of frames late, and then at least you got a 50-50 shot. So, that was a little early. That was E1. Okay, so I exited the elevator a little early, but I adjusted a little bit so it wasn't a perfect kill by one frame or so. It was also early. That was 1 frame late, 70. So you can see I shot my sword out, and the skeleton had to walk into my sword. That's going to delay by a frame or so. The reverse is also just, so that was C2, that was 1 frame early. The reverse is also true if you walk an extra pixel and then shoot your sword. That is going to delay a frame. That was early. That was E1 though, that's perfect. That's a pretty big bonk. Oh, I must have missed the stab. That was 1 frame late, that was 70. There's E1. .38 is 2 frames late. Missed that. There's E1. Elevator was a little bit up, or not quite at the top, so I walked a little forward. Okay, that was good. That was E1. Actually getting quite a lot. That's good. That one didn't feel right. Yeah, that was 2 frames late. 70 is 1 frame late. There's E1. Alright, so there's a bunch of ways of getting it. That's what I'm aiming for, is right when I'm hitting the top, it can be 1 pixel down. You start walking. You can, stab, like a low beam stab, so you're not hitting the shield and wasting frames that way. And then another crouching stab. Hopefully you get a bag.